Chapter 6 is about discrete functions. The 7 topics we'll be discussing in this chapter are 6.1 Sequences of Discrete Functions, 6.2 Recursive Procedures, 6.3 Pascal's Triangle and Expanding Binomial Powers, 6.4 Arithmetic Sequences, 6.5 Geometric Sequences, 6.6 Arithmetic Series, and 6.7 Geometric Series.
6.1. Let's start out with some key definitions. A sequence is an ordered list of numbers identified by a pattern or rule that may stop at some number or continue indefinitely. And an explicit formula is a formula that represents any term in a sequence relative to the term number.
And the term number is usually represented with the lowercase n.
Given the formula for the nth term, find t at 4. All we have to do is take our term number, the n, and sub in 4 wherever n is. So t at 4 works out to be 48. Another example like the previous one you may encounter is find the third term in the sequence. With this example again, all you have to do is sub in 3 into the formula. This example works out to be f at 3 equals 128. Recursive procedures. The definition of Fibonacci sequence is each number after the first two numbers is the sum of the preceding two numbers. In the example, 1 plus 1 equals 2, 2 plus 1 equals 3, 3 plus 2 equals 5, and 5 plus 3 equals 8. The definition of a recursion formula is a formula by which each term of a sequence is generated from the preceding term or terms. This question is asking us to find the first three terms of the sequence. They already provide us with the first term and the formula. It is a formula consisting of at least two parts. It not only finds the current term but also the previous term value. Here's the solution. This is how I got 13 and 11. Since t1 is already given to us, we can sub its value into the equation to further solve. So t1 minus t2 now becomes 15 minus 2. Similarly, when trying to find t at 3, we can use the previous value that we just found, which is t at 2, to solve. So t at 2 subtract 2 becomes 13 subtract 2. Now this example is a little trickier. The question asks us to find the fourth term in the sequence. Since we have both t at 1 and t at 2, like we did before, we can sub them into the equation to solve. T at 4 now becomes 22. This is Pascal's triangle. Every row starts with 1 and ends with 1. The numbers you see on the left-hand side represent the row number. The numbers on the left-hand side are not a part of Pascal's triangle, but only there to guide your understanding of each row number. As you may have noticed, the first 1 on the Pascal's triangle is not known to be row 1, it is row 0. One unique pattern with Pascal's triangle is that if you add up the two numbers above, you get the answer below. For example, in the fourth row, the number 6 comes from the two 3's added together above it. The 10's in row 5 come from the 6 and 4 added above it. The first question asks to expand and simplify a binomial. A side note, a binomial is two terms added or subtracted together. Using our Pascal's triangle, we must first look for which row in Pascal's triangle we will get our coefficients from. To do that, all we have to do is look at the exponent in our binomial. In this case, our coefficients will come from row 3 because our exponent is 3. Our coefficients are 1, 3, 3, and 1. In the second line, I have the first term. Using our Pascal's triangle, we must first look for which row in Pascal's triangle we will get our coefficients from. To do that, all we have to do is look at the exponent in our binomial. In this case, our coefficients will come from row 3 because our exponent is 3. Our coefficients are 1, 3, 3, and 1. In the second line, I have the first term in the binomial. The exponents are meant to decrease starting from the exponent number, so 3, 2, 1, 0. In the fourth line, you will notice that the second term in the binomial is to the exponent 0, As with the second term of the binomial, you must increase. So 1, 2, 3.
6.4 is all about arithmetic sequences. Arithmetic sequences are a sequence where the difference between consecutive terms is constant. The formula for arithmetic sequences is Tn equals a plus bracket n minus 1 bracket d, where a represents the first term, d represents the common difference, which is the difference between any two consecutive terms in an arithmetic sequence, and n represents the term number. Example number 1 asks us to find the first term and the common difference for the following sequences. In the first question, we know a equals negative 3 because that is the first term in the sequence, while the difference is just the second term minus the first term, which means 0 minus negative 3, which equals 3. Therefore, a equals negative 3 and d equals 3. In the second question, we have to confirm if the sequence is arithmetic. That's why I've inputted the term numbers for the explicit formula that was given. And then from there, we found out that term 1 equals 11, therefore equaling a, and we found the common difference the same way as we found in question 1, therefore d equaling 2. Therefore, a equals 11 and d equals 2. Then we substitute 12 as n into the explicit formula 5n minus 3 to get a total of 57. Therefore, the explicit formula for this sequence is 5n minus 3, and the 12th term for the sequence is 57. Example number 3 asks us to write an explicit formula given the recursion formula and the first two terms of a sequence. Once again, we need to confirm that this sequence is actually an arithmetic sequence. And to do that, I've substituted 3 into the recursion formula from where I got t2 plus 4, and we know that t2 equals 7. And then from there, I got t3 equals 7 plus 4, therefore t3 equals 11. And now we already know that the first term equals 3 from t1 equals 3, and the difference in the sequence is 4. And then from there we inputted all our givens into the arithmetic sequence formula to get an explicit formula of 4n minus 1. Therefore, the explicit formula is Tn equals 4n minus 1. Example number 4 is asking us to find the number of terms in the arithmetic sequence given. Before tackling this problem, we should first list all our knowns like I have on the left-hand side. Then we can input it into the arithmetic sequence formula to get a total of 16. Therefore, the number of terms in this sequence is 16. Example number 5 asks us to find the first term and the common difference given only two terms of a sequence. To tackle this problem, we should first make two separate formulas, where we input T11 equals 132 and T24 equals 288 into two separate arithmetic sequence formulas. From there, we get 132 equals A plus 10D, and 288 equals A plus 23D. After finding the formulas, we can subtract 288 equals 8 plus 23d from 132 equals a plus 11d to find the value of d. And remember, when you're tackling these kind of problems, always use the greater values to subtract from the lower value. And we get d as 13. After that, we input d into the formula we already have to find the value of a. And after inputting d, 13, which is 13, into the formula that we already had, 132 equals a plus 11d, we get a equals 2. Therefore, a equals 2 and d equals 13. 6.5 is about geometric sequences, and a geometric sequence is a sequence where the ratio of consecutive terms is a constant. The formula for geometric sequences is Tn equals ar to the power of n minus 1, where a represents the first term, r represents the common ratio, and n represents the term number. The definition for a common ratio is the ratio of any two consecutive terms in a geometric sequence. Example number 1 asks us to determine the first three terms of the geometric sequence. To find the first three terms, we simply have to input 1, 2, and 3 in substitution for n into the formula Tn equals 4 multiplied by 1/5 to the power of n minus 1 to get the values 4, 0.8, and 0.16. And therefore, the first three terms are 4, 0.8, and 0.16. Example number 2 asks us to find the number of terms in a given geometric sequence. This problem is similar to example number 4 in the arithmetic sequence section of this video. However, in this time, we just have to substitute the arithmetic sequence formula for the geometric sequence formula. Similar to that problem, let's first list all our givens on the left-hand side, like I have already. And then let's input what we know into the geometric sequence formula. From here, we can solve for n, which is the number of terms in this geometric sequence. Also remember, when we're solving these kind of problems, remember to divide the 36 and not multiply with the 3, because that will give us a wrong answer. Because we have to follow the bedmass rules, as we all should remember. And we get n as the final value of 5. Therefore, the number of terms in this geometric sequence is 5. Example number 3 asks us to find the first term and the common ratio given only two terms. Once again, this is similar to example number 5 in the arithmetic sequence section, except once again we're also using the geometric sequences formula instead of the arithmetic sequence formula. Like last time, we'll make two separate geometric sequence formulas using inputting T6 equals 224 into the geometric sequence formula and T8 equals 896 separately. And then from there, we get the two separate formulas, 224 equals AR to the power of 5 and 896 equals AR to the power of 7. Instead of d, this time we will be solving for r, and to do that we have to divide the greater value formula from the lesser value formula, and from there we get 4 equals r squared, and we square root that to get 2 equals r. Now we substitute the value of r into the previous formula we had, 224 equals ar to the power of 5, and from there we get the value of a, which is 7. Therefore, a equals 7 and r equals 2.
6.6 Arithmetic Series. When you hear the word series, the first thing that pops up in your mind would be your favorite television series or your favorite book series. Basically, a series is a number of things of the same kind or related nature coming one after another. An arithmetic series is a series in which the terms are added to produce a sum. Consider this arithmetic series for example. In this case, 2 is the first term and the next term experiences an additional 2. This shows a similar trend as the same number is added progressively. The sum of the series would be 42. But just to make life a little easier, there are two ways that can get you to the answer. The top one is used when d is not given and the bottom one is used when tn isn't given. The first term, a, is 2. The common difference between the terms d is 2 and the number of terms in the series n is 6. Now the same question can be solved using the formula. After plugging in the values into the formula, the answer can be determined by first solving for the brackets that results in an answer 14, which is then multiplied by 3 to produce the final answer 42. See how easy this was? Now, how do you find the sum of an arithmetic series if you're given the first few terms and a last term? Example 1. What is the sum of this series? From this, we can determine the values of a and d, but we don't have n. To find n, we need to find what term 58 is. So we use the formula Tn equals to a plus bracket n minus 1 times d, where a is 3, d is 5, and Tn is 58. After solving for n, it is determined that there are 12 terms in this series. So n is 12 and is plugged into its respective variable. 3 replaces A and 58 replaces Tn. 12 is divided by 2 to produce 6, and the brackets are solved to give us a sum of 61. After multiplying 6 and 61, the final answer is 366. Now moving on to word problems. You can pause the video to read the question. In this particular series, A is 4, D is 4, and N is 30. After plugging in the values, the brackets are solved first, thus resulting in 124, which is then multiplied by 15 to produce a sum of 1,860. 6.7 Geometric Series. Geometric series is a series in which the terms of a geometric sequence are added to produce a sum. Consider this geometric series for example. In this case, 2 is the first term, and to get to the next term, the preceding term is multiplied by 2. The sum of this series would be 126. The sum can be determined in a simpler way using the formula Sn equals to A bracket r raised to n minus 1 over r minus 1. We can find the sum of the previous example by plugging the values into the formula. A is 2, r is 2, and n is 6 to get a sum of 126. How do you find the sum of a geometric series if you're given the first few terms and the last term? Example 1. Determine the sum of the geometric series. From this, we can determine the values of a and d, but we don't have n. To find n, we need to find what term negative 243 is. So we use the formula Tn equals to ar raised to bracket n minus 1. Tn is negative 243. A is 1 and r is negative 3. Negative 243 can also be written as negative 3 raised to 5. The exponent is then solved where 5 equals to n minus 1 and then n equals to 6. After solving for n, we use the sum formula and plug in the values for the variables, and the resulting sum is negative 182. Now coming to a word problem for geometric series. You can pause the video to read the question. In this series, A is 25 and R is 2, but N is unknown. 25 and 2 are plugged into the respective variables and the equation is simplified, resulting in Sn equals to 25 bracket 2 raised to n minus 1. We can now use the equation from part A and plug 2 million instead of Sn. 25 is divided by 2 million to give an answer of 80,000. Negative 1 from the other side of the equal sign is added to 80,000 to produce 80,001. The ln function is then used to find n. After finding the ln of 80,001 and ln of 2 is divided by the ln of 80,001 to give n. Therefore, 16 prizes can be given out.